Keat, where are you? Ready? You okay?
Yeah, I'm okay. I think that I just sprained my ankle.
Oh, I think it's kind of serious. You should go hospital. Come and take it to hospital.
Yeah, okay.
Tomorrow.
Oh my god, Keat, are you okay?
Yeah, I'm okay. Doctor said that I need to walk like this for a few weeks, but I think it's okay. I'm never mind. Yeah, I'm gonna heal.
Alright, take care, man.
Yeah.
Wait, hi Miss.
Hi, Tze Yun. Hi, Audrey.
What's wrong with your leg?
Yeah, I just sprained my leg yesterday, but gonna heal after 1 or 2 weeks. Yeah. Don't worry, don't worry.
Okay, take care.
Just remind me that we have M case study to do.
Yeah.
So what about we use crutches as our topic?
That's a good idea. Yeah.
Is it okay?
Yeah,
Yeah,
I think it's
So
okay.
let's go with this. Right. Careful.
Hello, good day. I've been to the audience. We are group 3. We are students from group 3 for the Mechanics of Materials assignment. And I'm Vissagan, and this is.
I'm okay.
I'm Audrey.
I'm Ying. I'm Tze Yun.
In this video, we are going to use the auxiliary crutches as our real life example. So, in this case study, we will demonstrate 3 LOs from real life examples of movement.
So L1, to solve problems involving a body under actions of axial and torsional loads.
LO2, solve problem involving stress in beams.
LO3, to evaluate stress and deformation of biomedical devices due to compound load. So without further ado, let's get started.
Hi, I'm Tze and I'm going to present on L1, which is to solve problems involving a body under the action of axial and torsional load. Right, so for axial loading, given that the weight of subject is equal to 58 kg and when we convert into the Newton unit, we will multiply by 9.81 and we will get 568.98 Newton. And based on this photo as shown, we can see that the diameter of crutches metal beam is equal to 2.2 cm, and when we convert into radius, it will be equal to 1.1 cm. So, based on the data given, we can calculate the area of the section cut, area equal to pi r square, and we will get the answer at 3.8013 times 10 to the power of negative 4 meters square. Right, so since we assume the weight of subject is distributed equally in both sides of crutches, so the pressure which comes from the weight of subject experienced by a single crutch is equal to pressure equal to 568.98 Newton divided by 2, and we will get the answer at 284.49 Newton. And assume that the force is in tension, and when we calculate the normal stress, which the formula is equal to pressure divided by area, we will get the answer at 74748.402 kilopascal, which is in tension. Proceed to next, torsional loading. Given that the maximum allowable stress is equal to 75 megapascal and the diameter and radius is same as previous, which is 2.2 cm and 1.1 cm respectively. And from the data given, we can find the polar moment of inertia by using the formula pi over 2 multiplied by c to the power of 4, and we will get the answer at 2.298 times 10 to the power of negative 8 meter 4, and when we calculate the torque, we can get the answer at 156.8047 Newton meter. Alright, so that's all for me. Thank you.
Hi, I'm Audrey going to explain on Learning Outcome 2 to solve problem involving stress in beams. For assumptions, the subject's weight is 568.98 Newton after converted from kg by multiplying with 9.81 Newton. Since he used a pair of crutches, assuming subject's weight is supported equally to both crutches, each crutch supports half the weight of the subject, which is 284.49 Newton. We also assume that the handle of the crutches is made up of cylindrical beam, which placed in a horizontal plane with a diameter of 2.2 cm and the length of 11 cm. The normal force at each handle end needs to be above 142.5 68.25 Newton to support the subject's weight. If the normal force applied at the end of the beam is 142.25 Newton each, the bending moment will equal to 0. Therefore, we assume the force applied at each of the handle beam is 150 to be able to calculate the bending moment while supporting the weight of the subject. Thus, this will be the free body of the crutch, since force was acting on the handle at the center of the handle, and the weight of the subject was supported by two of the crutches. The free body diagram of the crutch will look like this, where half of the subject weight acting downward, supported by two normal force of the handle acting upward. So, from the free body diagram assumption and the assumptions made, to obtain the maximum bending stress in handle beams, we calculate the moment of inertia first with the formula of 1/4 pi r power of 4. Given the radius is 0.011 meter, we will get 1.15 times 10 to the power of -8 meter power of 4. Next, the bending moment at the crutch handle, assuming normal force applied is 150 Newton at each handle and beam. By knowing the sum of bending moment is 0, we can know that the value of bending moment is equal to 0.8531 Newton meter. Lastly, the maximum bending stress at the crutch's handle. After obtaining the value of moment of inertia and the bending moment, we use the formula of this. We will obtain the maximum bending stress, which is 816.01 kilonewton per meter square. So now I'll pass it on to Tze Yun for learning outcome 3. Thank you.
Hi, I'm Tze Yun. I would like to present to you the third learning outcome, which is to evaluate stress and deformation of biomedical devices due to compound load. In our studies, we evaluate stress and deformation of the aluminium beam of the adjustment area of the crutches. So from what we have measured and analyzed, here is the parameters we get. The weight of load is 284.48 Newton, which is Keat's weight. The length of the adjustment area is 0.385 meter. The diameter of beam is 0.022 meter, while the Young modulus of aluminium is 69 gigapascal and the maximum allowable stress is 75 megapascal. With all the parameters we get, we can first calculate the cross-sectional area of the beam before calculating the stress of the beam. So for cross-sectional area, formula pi r square is used, and the answer we get is 3.8013 times 10 to the power of -4 meters squared. Hence, the stress of aluminium can be calculated using the formula pressure over area, and we'll get 748.420 kilopascal. And lastly, to evaluate the deformation of aluminium, the formula PL over AE is used. P indicates the pressure, L is the length, A is the cross-sectional area, and E is the Young modulus of the aluminium. Since stress is the pressure over area, hence the alternate formula, which is sigma L over E, is used. By inserting all the values into the formula, the deformation of aluminium beam is calculated, which is 4.176 micrometer. So that's all from me. Thank you.
So in conclusions, by using a fundamentals theory of mechanics of materials, we can solve problems involving
A body under the action of axial and torsional load. Stress in beams. Stress and deformation of a body due to compound load.
Alright, I think that's all from us in this video. If you like this video, please give a thumbs up and share with your friends.
Like and subscribe.
Bye!
Run!
Rose blows in. Shot up and good. Too big, too strong, too fast.
What?
2, 3, go.
Oh, no, wait.
So in conclusions, by using the fundamental theory of mechanics of materials, we can solve problems involving.
It was at this moment that he knew. He fucked up.
Alright, I think that's all from us in this video.
Wiggle, wiggle, wiggle.